Welcome everyone to Algebra 2, Section 4.3, Absolute Value Functions, Equations, and Inequalities. This time we are solving inequalities. So, in example 1a and b, we are using graphs in order to solve these. So what this is, on example 1a, is we have the absolute value x of x plus 3 and then plus 1, and we're saying, hey, is that greater than 4? Or where is it greater than 4, really? So here, what we're saying is, we have the line y equals 4 graphed right there. And we have the absolute value equation x plus 3 plus 1 graphed right there. We see it's 3 to the left because of the plus 3, and it's 1 up because of the plus 1. And then it has a slope of 1 and negative 1 because the a is 1. So now we want to know, hey, where is it greater than 4 though? So where is it above this line? And we see those two spots. So we say, okay, the two places it's above that line are when x is to this side of negative 6. So when x is less than negative 6. And the other spot, it also is that over here to the right of this. So when x is greater than 0. Now when x is equal to 0, it's equal to 4, so it's not greater than 4. When x is equal to negative 6, it's equal to 4 up and down, so it's not greater than 4. But when it's to the left of negative 6, so less than, and when it's to the right of 0, so greater than, they are above that line of 4. So these would be our two answers, that x is less than negative 6 or it's greater than 0. We don't put and on this one because they can't be both at the same time. X could be either one or the other. And what this means is if you plug in a number less than negative 6, such as negative 7, into the absolute value and add 1 to it after that, it would be greater than 4. And if you plug in something greater than 0, like 1, for example, into the absolute value, and then continue on simplifying, you to get something greater than 4. On to example B. We have to graph this one on our own. So you can start by graphing the absolute value part, the absolute value of x minus 2 minus 3. I suggest you try graphing that on your own. So the graph is going to go 2 to the right and 3 down for the vertex. So we do 2 right, 3 down, and the slope is 1. So we draw that in each direction. And then we want to compare it to the line of 1. So I'm going to go to y equals 1 and draw a perfectly horizontal line. Whenever we compare them to a number like this, when it's less than, greater than, we're always going to do a horizontal line at that number. And if you want to write that down in that, hey, we're doing a horizontal line at this number, might be a good idea for you. So we want to say, okay, where is it less than that or equal to it? So it's not less than here, it's not less than here. It's equal to it here and here, and it's less than everywhere between it. So what we say is, okay, well, it starts being less than it or equal to it at negative 2. And it's that way until it hits 6. So what we'll say is that x is between negative 2 and 6. So when negative 2 is less than x, aka when x is bigger than negative 2 or equal to it, that would be this part of the graph here. We'd be talking about anywhere from here to here, really. We're saying, hey, whenever it's greater than negative 2, actually, so anywhere from here. But then we have to stop and say, well, actually, but it doesn't go forever that direction. It only goes until it hits 6. So after it's equal to 6, we put the or equal to on that, and less than 6, it stops being that way. So as we look at this, if you were to plug in anything between negative 2 and 6, and including those two numbers, into our absolute value, and then simplify, you would get a number that is less than or equal to 1. So that would be our answer. Now, how are we going to solve without a graph? This is what we'll do a lot more often. So you can either have the absolute value of something is greater than some number c, like we had on example 1a, it's greater than 4, or you can have the absolute value of something is less than c, like we had on example b. And we're going to split these up into two categories. So the less than we'll talk about first, and we're going to call them less than. Because if you notice, the one where we did less than ended up being, hey, this scenario and this scenario overlapping. So what we'll do for that is, hey, I'll draw on, first of all, our inequalities. So less than and less than are equal to, or as we'll say, less than, combining than and. And we're going to write one equation, and it's going to be take your c, and you're going to do a positive and a negative c. And we're going to do our inequality, so whether it's less than or equal to, you write that inequality twice, and then you put whatever's in the absolute value thing there, okay? So in this case, ax minus b. Then we'll also have our greater than inequalities. But before we go on to the greater than inequalities, or greater than, which we're adding in the word or to it, we're going to first practice some less than. Okay, so let me talk about those, and I'm going to come back to this in the notes. So on example 3, we have the absolute value of x plus 2 is less than or less than 6. So what we're going to do is we're going to make two equations, or excuse me, one equation, one inequality really. So we're going to take the c, which is 6, and we're going to make it a negative 6, and we're going to make it positive 6. And then we're going to do our inequality twice, so it's less than. Then we're going to put whatever's inside the absolute value in the middle. And that's our setup. So once again, because it's less than or less than, you smush two inequalities together, and you have in the middle, what was in the inequality, what was in the absolute value. I mixed up my word there, I apologize for that. And on the ends, you have the positive and negative 6, with the negative being on the left, because you do the lower number on the left. Now we say, okay, well, x is not by itself yet, so we subtract 2. But now we're faced with the dilemma of, well, typically we subtract it from both the left and the right. But what do we do when there's a left, right, and a middle? Because there's the left, there's a middle, and the right. So we actually do it to all three parts. So when there were 2, we did it to both. When there's 3, we do it to all 3. Well, 2 minus 2 is 0, so we're left with x. Negative 6 minus 2 is negative 8, and we still have our less than inequality. And 6 minus 2 is 4, and we still have the less than inequality. So our answer ends up being negative 8 is less than x, which is less than 4. So we're going to turn to our graph here, like we did with the equations. I'm going to put 0 in the middle, and I'm going to go for negative 8, 8 tick marks to the left, 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to do an open circle because it's not or equal to it. For 4, I'm going to go 4 to the right, 1, 2, 3, 4. And I'm going to do an open circle because it's not or equal to it. And then you can draw this a couple different ways. So it's going to be whatever's in the middle of those, because x is in the middle of those. So you can either like connect them in the middle. So you can just do a straight line if you can see that. You can do kind of a squiggly line if that helps you see it better. Or something I like doing is I like doing it up here. So just doing like, hey, here's a straight bar kind of a thing between the two and connecting them. That way we can see it a little bit easier so it doesn't confuse us with this line that's already there. So whatever you want to do. I prefer this last one that I did, but any of them, as long as you have them connected in some way, shape, or form, are great. Because this showcases, hey, it's not quite negative 8 and it's not quite 4, but it's anywhere between those. All right, letter B. This time we also have a less than, but before we make the inequality stuff, we actually want to get rid of this minus 2. We want to get the absolute value by itself, just like we did with the equations. So we're going to add 2 to both sides and get the absolute value of 2x plus 1 is less than 9. Now we're going to put the negative 9 is less than and the less than 9. In the middle, put the 2x plus 1. So we do that after we get the absolute value isolated or by itself. Now we have to get x by itself. So we subtract 1 to the left, right, and the middle. and we get negative 10 is less than 2x, which is less than 8. I'm going to move my work up here because I ran out of space. Let me kind of redo this arrow. There we go. And I'm just going to rewrite what we had. All right, then for my next step, I'm going to divide everything by 2, left, right, and middle. So I get negative 5 is less than x, which is less than 4. And now my x is alone. So I go to graph. So I have 0 in the middle. Then I'm going to go 5 to the left, 1, 2, 3, 4, 5. Do an open circle because it's not or equal to. 4 to the right, 1, 2, 3, 4, open circle. And I'm going to connect them. So once again, I like connecting them this way. If you want to do this or just this, you're welcome to, as long as you can see it. Letter C, I'm going to recommend you do on your own. All right, letter C. So the absolute value is already by itself. So I'm going to do the negative 4 is less than or equal to this time, because that's the inequality. 7 minus x is less than or equal to 4. So I'm going to subtract 7 from the left, right, and middle. Get negative 11 is less than or equal to negative x is less than or equal to negative 3. Now I have to get rid of this negative, so I'm going to divide by negative 1 on the left, right, and middle. And I get 11x and 3. But an important note is that when you divide or multiply by a negative on every part of the inequality like we just did, you have to flip the inequalities. So might be a good idea to write that in as a note. Say, hey, a little note that flip the inequality when you multiply, I'm going to abbreviate, or divide by a negative. So we multiplied or divided, so we divided by negative 1, so we have to flip the inequalities. So now what we're going to do is we actually want the smaller number, the 3 on the left, and the 11, the big number, on the right. So we're going to switch it around again. So we're going to do the 3, the x, and the 11. But we have to know that, hey, the x is bigger than 3, so we have to make it the 3 is less than or equal to x, and x is bigger. And the 11 is bigger than x, so we have to keep it that way. So the new thing on this one was we had to flip the inequality. You probably didn't know how to do that, so you might have messed that one up. That's okay. So now for the graph, they both exist on the right-hand side. So 0 in the middle, 1, 2, 3. Close circle because it's equal to it or equal to it. 4, 5, 6, 7, 8, 9, 10, 11. And they'll connect in the middle again. All right, I'll encourage you again to do letter D on your own. Letter D, I have to divide by 3 first because it's not part of the absolute value. And I'll do 2x plus 1 is less than or equal to 9. Oops, the absolute value of that. Now, I put my negative 9 is less than or equal to 2x plus 1 is less than or equal to 9. Subtract 1. Negative 10 is less than or equal to 2x is less than or equal to 8. This looks oddly familiar. You might notice it looks a lot like letter B did, huh? So, continuing on, I'm going to write this one up here. Negative 10, less than or equal to 2x, less than or equal to 8. Now divide by 2. X is less than or equal to negative 5, which is less than or equal to 4. So graph it. 1, 2, 3, 4, 5. Negative 5, close circle. 0 in the middle. 1, 2, 3, 4 to the right. Close circle. Going in the middle. So now for our greater than inequalities, we're going to talk about those next. So this is greater than or equal to. We're going to write two inequalities. It says equations. They're really inequalities, though. And the first one, you might need to write them below because there's not a lot of room, is the ax minus b, so whatever's in the absolute value, and we're going to do is less than c. See me? That should be is greater than C. And your second one's going to be the ax minus b is less than negative c, the opposite of it. So for your second one, you flip the sign and you make the right side negative. So just like with the equations, we had to make two of them, the right side became negative. When you make two of them, the right side becomes negative, and we flip the inequality. Okay, so in order to practice it, we're going to go on to the next page. And once again, we're going to talk about, hey, yeah, we're going to set up two inequalities as equations, really inequalities. So you have your absolute value of whatever's in the middle, we'll call it x for now, is greater than a number because it's greater than. So we're going to set up 2, and it's going to be x is greater than that number, so c like we talked about, or x is less than the negative number, the c we were talking about. And we're going to put the word or instead of that we're doing, hey, this and this, they meet in the middle. We'll see what happens instead. On example 4a, we have to get the absolute value by itself just like we did before, by dividing by 2. So we get the absolute value of 3x minus 7 is greater than or equal to 5. So now we split them. 3x minus 7 is greater than or equal to 5. 3x minus 7 is less than or equal to, flip the sign, negative 5. And it's going to be this or this being the case. And we solve each inequality. At 7, 3x is greater than or equal to 12. At 7, 3x is less than or equal to 2. Divide by 3, divide by 3. X is greater than or equal to 4. X is less than or equal to 2/3. And this is this or this would be our answers. So we'll go ahead and graph it as well. Going to 0, 1, 2, 3, 4, close circle, and 2/3 would be about here. And less than 2/3 is going to go to this direction. Greater than 4 is going to go that direction. And if you were drawing these on the line itself, it'd look more like this. And you need those arrows because it's going forever in that direction rather than meeting each other in the middle, because it's this or this. So that would be more similar to the first graphing problem we did today, this or that. Letter B, go and try this one on your own. All right, so we have x plus 4, the absolute value is already by itself, so we start by splitting it. X plus 4 is greater than or equal to 6, that one's normal. X plus 4 is less than or equal to, flip the sign, negative 6. Solve each. Subtract 4. X is greater than or equal to 2. X is less than or equal to negative 10. So, graph them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Less than negative 10, these numbers are less than it, like negative 11, negative 12, so on and so forth. 0 is not less than negative 10, so we go away from that. 1, 2, close circle, greater than 2 would be to the right. And those were the answers. Letter C, try this one on your own. Absolute value is by itself, so we'll make two inequalities. 4x plus 5 is greater than or greater than 13. 4x plus 5 is less than negative 13. Start by solving. Subtract 5, subtract 5. 4x is greater than 8. 4x is less than negative 18. Divide by 4. X is greater than 2. X is less than or equal to 9 over 2. Or negative 4.5. Graph 0 in the middle, 2, 3, 4, 5. We said negative 9 over 2 is between negative 4 and 5, and less than that would be to the left. Greater than 2, open circle, is to the right. So those are our answers. On to D, once again, try this one on your own. Absolute value is by itself, so we make two inequalities. 2x plus 7 is greater than 1. 2x plus 7 is less than negative 1. Subtract 7. 2x is greater than negative 6. 2x is less than negative 8. Divide by 2. Divide by 2. X is greater than negative 3. X is less than negative 4. These are very close. That's okay. 0 in the middle. 2, 3, 4. And we have 4 and 3. Negative 4, negative 3, I should say. Open circles at both. X is greater than negative 3. That's going to go to the right. X is less than 4. Negative 4, that goes to the left. You might notice here actually, that when X is on the left, this kind of looks like the arrow as we go to the right. When X is on the left, this kind of looks like the arrow as we go to the left. So when X is on the left, we can kind of match that as an arrow as well. On to some application. Woo! A box of cereal is supposed to weigh 13.8 ounces. But it's acceptable for the weight to vary as much as 0.1 ounce. So not a lot, but a little bit. Write and solve an absolute value inequality to find the range of acceptable weights. So how we would do this is we know we want it to be 13.8 ounces and it could be off by as much as that. So no more than that we wouldn't say, right? So we're going to do the absolute value of x minus 13.8. And what x is going to represent is the high and low of what it could be, or the acceptable range, really. And so we're going to say, hey, we're going to take that and subtract that target number we really want to hit. The 13.8 ounces is what we really want. And we say, okay, so how far off it can be no more than or as much as, so it has to be less than or equal to 0.1 ounces, or 0.1. And that would be our inequality. As we start solving, I think we'll realize why this is the case, why the setup's the case, and I'll re-explain that too. So we have the absolute value by itself, so we'll set up two inequalities. We'll have negative 0.1 is less than, less than is less than, x minus 13.8 is less than 0.1. So we add 13.8 to the left, right, and the middle, and we get 13.7 is less than x, which is less than 13.9. So even as we look at this, can we notice that, hey, 13.7 and 13.9 are both 0.1 ounces off? Yeah, they are. Oh, excuse me. And I lost my or equal to along the way. A lot of you probably had that and were like, whoa, Mr. Cross, what are you doing? So x is between those two or equal to it. And yeah, that would make sense because 13.8 is between those. So it can be anywhere from 13.7 to 13.9. So that's why we had to do the less than that. Now, if you wanted to, you definitely could do negative x plus 13.8, aka the same thing as 13.8 minus that is less than or equal to 0.1. It would accomplish the same thing. So really, you just want to do your target weight and your range, so your x, your variable, subtracting each other. On 6, I want you to try it on your own. All right, so hopefully you've already read it by now, and we want the incumbent, or we're saying that the incumbent will get 51% of the vote. But the poll could be off by as much as 3 percentage points. So it shouldn't be off less, or something more than that. It should be off like even 3.5 percentage points. But it should, it's able to be off anywhere up to 3, including that. So we do the same kind of setup we did on 5. The target and the variable subtracting. So x minus 51, because we're saying, hey, the poll's showing 51%. As much as, so it can be up to that, but not more than, so less than or equal to 3. That range it could be in, how far off it could be. Like last time it was 0.1 ounces, this time it's 3 points. Absolute values by itself, so we make the two inequalities. This is less than, so we do the negative 3, less than or equal to x minus 5 is less than or equal to 3. Solve by adding 5 to each side, and you get 2. See me, I lost my 51 in there again. So it's not 2 at all. It is instead going to be 48. Is less than or equal to x, which is less than or equal to 54. So that's our possible range of percentage points. So you do 51 minus 3 and 51 plus 3 at the end of the day, with this inequality. All right, so big picture real quick as I recap this section before I end it is really when we're doing absolute value inequalities, we're going to have to make two inequalities regardless. What kind of inequalities we're making all determine on what our symbol is, whether it's less than or greater than changes it. So if you can remember those two things, you can have quite a bit of success